In this video, I wanted to introduce everyone to the newest course over at powerup.sd-geeks.com. This is the CCIE Fast Track course. It is designed specifically to help people prepare for the CCIE Enterprise Infrastructure exam in Section 2, focusing on SDA and SD-WAN. I wanted to do a brief walkthrough on the course and discuss what it is I was trying to accomplish in its creation. So fundamentally, I wanted to create a training that was going to be very, very focused on addressing what Cisco is expecting in the context of the Enterprise Infrastructure Lab exam. So if we look at the blueprint, we're going to see that there's going to end up being a huge swath of topic domains that individuals need to be familiar with, need to study, and obviously need to have experience with from the perspective of design as well as deployment, operation, and optimization. So what I tried to do is I tried to take an analytical look at all of the information associated to the topics that have come up in individual interviews and discussions with people who have taken the exam and create a holistic approach to be able to address the concerns of the exam. So fundamentally, the introduction section is basically just introducing everyone to the topology, to how the labbing is going to end up being done, and obviously to myself. The next section is going to be addressing the design theory. Many students that are taking the exam currently are passing the configuration phase, in other words, the DOO phase, but they're failing design. So I wanted to try to make certain that I spent ample time discussing everything from a theoretical perspective in individual isolated sections. So instead of confounding deployment with design, I separated each of these individual topics. So inside of the SDA design theory, we need to talk about and understand what SDA is. Software-defined access, the concept of tunnels, how these things get implemented, the involvement with technologies like VXLAN, Lisp, and CTS. Then I go into a further explanation and description of the individual enabling technologies that make SDA a thing. Locator ID separation protocol, VXLANs, or Cisco TrustSec, which gives us the idea of SGTs and SGACLs and 802.1x supplication, etc., for both wired and wired hosts. And then ultimately a conversation about PX Grid and extensible messaging and presence protocol, which is going to end up being the protocol that enables the Identity Services Engine and the DNA Center to exchange information and to interoperate. So again, the whole concept behind this was to introduce all of the theoretical concepts so that we can use them. And use them is exactly what we're going to end up doing in the next section. So I added a bonus section on how to build a cluster, just in case there were some design questions asked about that. That's going to be 6 videos. They're not very long. And for the most part, I thought it was important for everyone to at least see that being done. However, when it comes to handling the deployment in the context of getting a DNA Center / Catalyst Center to work with network devices, meaning switches, we had 2 different ways to go. So for individuals that do not have any physical resources in their environment, I created a lab environment that is a mock lab deployment where we will be using Catalyst Center version 2377 in concert with virtual 9K switches inside of CML2 or inside of EVE-NG. Now, all things above the board here, I had some issues with CML2 when it came to implementing LAN automation, so I ended up having to create an alternate lab. However, the environment that I built inside of EVE-NG, the LAN automation worked perfectly fine with the images that I had. So I'm just going to go ahead and say that now so everybody's aware of it. But I'm trying to create an infrastructure and a labbing environment where you can use whatever emulation platform you choose to use, whether that's CML, GNS3, or EVE-NG. I only work with EVE-NG and CML2. So in task 1, we integrate the DNA Center and the Identity Services Engine. Also, I thought it would be necessary to give a bonus video on how to patch the Identity Services Engine, as well as how to ensure that synchronization is taking place between the 2 platforms. We create the network hierarchy, and that's going to include sites, pools, credentials, etc., and also looking at the idea of inheritance in the hierarchy. We are then going to, in the lab, we discover a single device. We're going to discover a single virtual 9K in what is referred to as branch 1. And after we discover that, what we do is we create our SDA fabric site, and we are going to build a transit network. From there, we go ahead and create virtual network and scalable group tags, validate same. We're going to then create a fabric and a box deployment. And then from that fabric and a box deployment, I execute a LAN automation, and we discover the second switch in that site. If you are running CML2 and you can't get that to work, it did work perfectly fine in Eve. But if you cannot get it to work in CML2, I give an alternate lab for lab 7, which is going to end up being just going through the discovery process like we did in task 3. From there, we are going to onboard our hosts. These are going to end up being our wired endpoints only, obviously. This is going to be in the form of, let me go ahead and log into the topology here. So this is the Eve instance. So these are the 2 devices that I just brought on board, and then we're going to end up adding hosts. The first host will be connected to gigabit 106. The second host is connected to gigabit 107. And in this lab, what we're going to end up doing is we are going to end up applying these resources in such a way that we are going to first look at the idea of microsegmentation. So when we onboard these hosts, we're actually going to assign SGTs to the 2 devices. In fact, in this class, we'll use students and teachers. And then given the fact that our endpoints are part of the same virtual network, branch 1_campus, we demonstrate how microsegmentation works using SGTs and SGACLs and how to verify them inside of the Identity Services Engine. From there, we are actually going to take the second host and place it into a separate virtual network. And while it's in that second virtual network, we will demonstrate the fact that we're going to get macro segmentation until such time that later on in the SD-WAN lab, we implement a route leaking operation. So also for individuals that do have access to physical switches, I have a walkthrough where we do pretty much the exact same lab using DNAC in 2337. Using those physical switches, I'm adding this as bonus content. The reason being is that I want you to be able to see how it functions and what it looks like in the 2 different versions of software so that you guys can make comparisons. So from there, we need to understand what's going on in SD-WAN. So I cover detailed lectures on the overlay and the underlay routing requirements. We talk about control plane connections. We have an in-depth lecture on SD-WAN theory and operation with regard to controllers. And then ultimately, we're going to turn our attention to the protocol where, quote unquote, the rubber hits the road in SD-WAN, and that's going to be overlay management protocol and its corresponding best path selection mechanism, to include the conversations about the different types of OMP routes, V routes, TLOC routes, and service routes. So with this, the whole object was to try to make certain that we talk about everything that we need to know from the aspect and the purpose of design, to include understanding how macro segmentation takes place inside of SD-WAN. We share common IPsec tunnels between edged resources in our environment, and traffic for one VPN is isolated and kept separate from the traffic in another VPN through the utilization and deployment of labels. So again, these are going to end up being comparative. VPNs are going to correspond to virtual networks, and obviously both VPNs and virtual networks correspond to VRFs, depending on which particular component in the lab you're looking at. And then from there, once we understand how to handle our deployment in the form of templates, we really need to talk about policy constructs. So how do I dictate behavior? How do I implement things like arbitrary topology architectures? How do I do application-aware routing? And then from those, what are those policy architectures going to look like? And then once we talk about them from the perspective of their architecture, we need to recognize that they're going to end up having different areas of enforcement where we have centralized policies versus localized policies. So I tried to cover all of the theoretical components in the exam in a single isolated spot. So from there, what we end up doing is we're breaking SD-WAN up into 2 different mock lab scenarios. The first is going to end up being the mock lab build, which is pretty protracted. It's going to require us to build our vManage, our vBonds, and our vSmarts, and we will be using the concept of self-signed certificates to get those devices up and operational. And so everyone knows I did run into a problem in CML2 getting the self-signed certificates to work. I'm currently trying to troubleshoot what's causing that. I think it's got something to do with the machine, the Linux machine that I use to sign the images. I'm going to give it a try and see if I can't work it out. And once I do get all of the CML2 stuff worked out, I will provide the topology files. The only files that I have currently up that are operational right now are going to end up being those images for EVE-NG since it works 100%. So in the fourth exercise, we're going to create a feature-based template for the headquarters site. And then using what I show you in that lab, I'm going to expect you to go ahead and onboard the 2 other devices. So if we look at the topology, we have CEdge-11 in Site 1, and we have CEdge-21 in Site 2. So that's going to end up being a challenge lab. Now, the challenge labs have no safety net. So obviously, I record a solution for them, but there are no step-by-step instructions on how to accomplish these. I am working on an accompanying lab guide, and you can see in the class, in the recordings, I do have a lot of pages. I'm just right now trying to get everything edited to where it's all neat and organized. So from there, we move into task 5, where we're going to configure a feature-based template for branch 1. We're going to create a basic feature template for branch 2. We're going to add the MPLS transport to all devices because we originally start with just business internet. From there, we're going to configure our service-side VPNs. So from there, we are going to go to task 9, where we're going to update the device templates to incorporate those VPNs. And in this, we're only going to do that in Site 10, which is going to be the headquarters site, which is going to end up being up here. And then from there, I have a challenge lab where I'm going to ask you guys to go ahead and handle that implementation in Sites 1 and Sites 2 on CEdge-11 and CEdge-21, respectively. Task 10 is going to be deploying OSPF in the headquarters office, and Lab 3 solution is going to end up doing that on CEdge-2. So the walkthrough on Task 10 will do CEdge-1, and Challenge Lab 3 will have students do the same deployment on CEdge-2 with no safety net. Task 11 is going to be configure service-side routing in branch 1, and that's going to include BGP. This is going to complete our layer 3 handoff scenario in SDA that we built when we build and assign a border node. And we're going to do this specifically for VPN 3001. In Challenge Lab 4, again, with no safety net, I'm tasking the students to go ahead and handle the exact same implementation for VPN branch 1 guest and VPN 3002 in the SD-WAN environment. From task 12, we're going to create a single uplink template for CEdge-1, and that should be CEdge-2. I'm going to have to edit that and fix it. But this is going to allow CE1 to be singly connected to business internet, and CE2 will be singly connected to MPLS. And then in task 13, we're actually going to deploy a layer 2 TLOC extension in headquarters. So if we take a look at that environment, that means this device is only going to be physically connected to business internet. This device is only going to be physically connected to MPLS. And then what we're going to end up doing is we're going to create a layer 2 extension using subinterfaces using layer 2 TLOC extension through headquarters switch 1. So that's what that's going to look like. And then we're actually going to do that on CEdge-1 and extend business internet to CEdge-2, where CEdge-2 will have to create a tunnel. And then in the challenge lab, I'm going to have you do the reverse of that, again, with no safety net. From that scenario, you're going to extend MPLS on CEdge-2 via the layer 2 TLOC extension to CEdge-1 so that it will actually be quote-unquote dual attached. From there, we're going to enable network address translation such that we are going to use a NAT DIA in the headquarters office to assure that any resource in the assigned VPN can get to the internet. So if we take a look at the topology, that means this resource right here should have the capability of being able to get out of headquarters site 10 and allow that traffic to travel through the underlay to go out through the ISP connection. And we do that again with NAT DIA. In the challenge lab solution, we're going to end up doing that on a second router. So this guy is the walkthrough to do this on CEdge-1, and this will be the no safety net to do this on CEdge-2. So from there, we should have a firm understanding of how we're going to implement our intent with regard to configuration through the utilization of templates. That opens the page for May mock labs using policy. So the first policy that we're going to do is we're going to architect a hub and spoke infrastructure for VPN 3001. And then what we're going to end up doing is in the challenge lab, we are going to go ahead and expand that. So from there, the next thing is that we need to consider the fact that inside of, say, for instance, branch 1, we still want to have DIA, but we don't want to use a NAT DIA. So we don't want to have a static default route showing up in our routing table for a service-side VPN that is going to be pointing to VPN 0. Instead, what we're going to want to do here is we're going to do that by policy. This is going to involve the fact that I'm going to have assets attached to the SDA that are going to be provided DIA service from the SD-WAN managed resources. And as such, we're going to need to do a little bit of troubleshooting and take an analytical look at what's going to be happening in the infrastructure so that we can overcome some routing shortfalls. Then, once that's done, we're going to do route leaking in branch 1. In my lab, if we take a look at the headquarters router 1, we actually configure DHCP on this resource, and that DHCP service is going to be tied to a single VRF, in this case, 3001. Now, that means that host 1 in 3001 will be able to send or get a DHCP address because it's going to send its discovery request to this device where there will be an IP helper command that's going to point to 10.255.255.1, which exists all the way up here in a different site. So that means that that request is going to get VXLAN tunneled to branch 1 cat 1, is going to get sent via IP to CCIE-level using the BGP layer 3 handoff that we created, and then end up being IPsec tunneled towards the headquarters office. And as such, the DHCP server is going to exist inside of that virtual private network, or that VRF in this case, of 3001. However, that gives us a dilemma because 3002 is going to be connected to, and is connected at this point of the lab, to branch 1 underscore guest. So when that goes all the way up to CCIE-level, the problem is there's not going to be the presence of a route to anything in headquarters site 10 that is going to be in the VRF of 3001 because of the fact that that is a macro segmentation construct. So in the lab that we're looking at, we're being tasked to perform route leaking in branch 1. So I want to take routes from 3001 and leak them into 3002, and I want to take routes from 3002 and leak them into 3001, and we're going to need to take a very close analytical look at how that policy needs to be created, and that's going to force us to really consider the concept of policy directionality. So again, very, very fun lab to actually implement. Then we are going to implement an application-aware routing process where we're going to look at things like our application-aware route policy, being able to pin particular types of traffic. I do it based on IP protocol, and also in another scenario, I do it based on DSCP values to be able to ensure that we can pick the path that traffic is going to traverse when all of our traffic paths are in scope. However, when our traffic paths are out of scope, we also want to look at what's going to happen in certain situations when a single path is out of scope or when multiple paths are out of scope, aka all paths are out of scope. We only have 2 in this lab. You know, what are our options when we start looking at things like the concept of best path, looking at the idea of strict, what would we refer to sometimes as drop or load balancing? We take an analytical look at those. And then in the challenge lab, what we're going to end up doing is that when we create each of these individual policies, they are standalone policies. Those policies are going to correspond to specifically what the task says. So this policy will do hub and spoke. This policy would do DIA. This policy will do route leaking. This policy would do application-aware routing. However, in Challenge Lab 8, we're going to create a single policy deployment construct that's going to allow us to be able to simultaneously deploy all of these resources and all of these policies at a single time. So I wanted to walk through this to show you what was inside of the course, and specifically, I also want to highlight how many classes there are. So right now, there is in the class 66 lessons, 27 hours of content. The course is complete, and the course is available now at powerup.sd-geeks.com. And I will be adding new content to it as time progresses. So as I do more interviews, as I talk to more people, as I begin learning more and more about things that we need to cover, I do plan to add more content to this class. I am in the current process of working on a formal lab guide, and once that lab guide is done, access to it will also be provided as part of the subscription or the enrollment. So I wanted to make certain that everybody was aware of this. I'm really, really pleased with it. I am extremely happy with the way that it turned out. Obviously, I'm going to be editing and doing some tweaking and adding some additional bonus content when and how time allows. But again, I just wanted to let everybody know about the class's existence, outline what it is, and encourage anyone that's interested to go ahead and sign up. I'll put the link down into the description of this video. So till then, I hope everyone has a great weekend, and I will catch up with everyone later.